Welcome back to it. It's Maths Masterclass with Leo. Today we are doing Laplace transform. Maths 2. Laplace transform, not Laplace method. Laplace transform. This is our second lesson on Laplace transform, and we are proving this 3 today. In the previous video we proved 1, 2, 3. Today we are proving sine, cos, and t, right? So we want to know if indeed the Laplace transform of sine at is equals to a over s squared plus a squared, right? And indeed the Laplace transform of cos at is s over s squared plus at. So let's begin. So we will have f of t in this case, or f of t in this case being equals to sine of at, sine of at, right? And meaning we're doing the Laplace transform of sine at, right? This is equals to the integral from 0 to infinity of e to the power minus st into sine of at dt, right? Definitely you can see that this requires us to use integration by parts. So let's do that. We're going to integrate by parts. Okay? Let me just erase this. We're going to integrate by parts. Okay. So okay, then we will use detail. This is our way of knowing which one to integrate and which one to differentiate. So in this case, we have exponent and trig. It means we're going to differentiate trig and integrate exponent, right? So differentiating trig, we will have, this will be sine of at, right? This is plus, minus, plus. Then integrate e to the power minus st. When I differentiate sine of at, I'm going to get a cos of at. When I integrate e to the power minus st, this will be e to the power minus st over negative s. When I differentiate a cos of at, it will give me negative a squared sine of at, right? This will give me e to the power minus st over s squared, right? After that, I'm going to multiply this and that, this and that, this and that, because it doesn't give me a 0 at the end, so I need to continue with it. So this will be equivalent to, this is e, which is negative e, negative st over s sine of at, right? Then minus a cos of at. Okay, let me start with e. This will be e to the power negative st over s squared multiply a cos of at. Lastly, we will have negative e to the power negative st over s squared, then a squared sine of at, right? So since this cannot give us a 0, we must introduce an integral sign, right? And then this, the integral of what? The integral of e to the power negative st sine of at is equivalent to e, which is negative e to the power minus st over s sine of at minus e minus st over s squared a cos of 80. Then lastly we will have the integral. Let me remove that detail. Lastly we will have minus the integral of e to the power minus st over s squared a squared sine of 80. Right? Rearrange, take this to the other side. Why? Because I have common factors, which is e to the power minus st and sine 80. So I'm going to take this integral sign to the other side. This will be the integral of e to the power minus st sine of 80 plus the integral of e to the power minus st over s squared, this a squared sine of 80. It's equivalent to, then here I can just say my lowest common multiple is s squared. S into s squared is s multiplied by, this will be negative s e to the power minus st sine of 80 minus s squared into s squared is 1 multiplied by e to the power. This will give me, let me erase this part. So that we have some space. Okay. And now this will be negative e to the power minus st a cos of 80. Right? Then I can take out a common factor, which is the integral of e to the power minus st sine of 80. In bracket, I'm going to have 1 plus, here I'm going to be left with a squared over s squared being equals to over s squared negative s e to the power negative st sine of 80 minus e negative st cos or a cos of 80. Right? When I divide by this, this is going to be the integral of e to the power minus st sine of 80 into, this will be s squared plus a squared, which this, I just simplified the fractions. This giving me, I can take out e to the power minus st as a common factor, which will be e to the power minus st, into s multiplied by sine of 80 minus, plus a cos of 80 over s squared. Right? Then let me just scroll down if possible. Let me just go to the next page because I think I can't scroll down here. Let's do that. Next page. Here I still have my integral of e to the power minus st, right? Sine of 80. This is equals to negative e to the power negative st, then sine or into s multiplied by sine of 80 plus a cos of 80. Divide by s squared. So in this case, multiply by, I had s squared plus a squared over s So when I divide by it, it will change to s squared over s squared plus a squared. So this is what I'm going to have here, which is s squared over s squared plus a squared, which s squared and s squared will cancel. Then I'll be left with negative e, negative st, right, into s multiplied by sine of at plus a cos of at over s squared plus a squared, right? Then now this must be substituted on that Laplace. So you can just say here, to make things easy for yourself, this will be from 0 up to infinity, right? Why am I saying that? If you can check here, where is it? If you can check our previous page, here, okay, it's a bit slow, but yeah, we're getting there. Now I substituted what? The solution that I got, I substituted it where? Here. Okay, I integrated. Then when you integrate this is the solution that you're gonna get, which is in the next page. The solution that you got in the next page is the solution for integrating sine or e to the power minus st sine of at, right? But remember, we are given conditions from 0 to infinity, so we can substitute, right? When we substitute, this will give us, when you substitute infinity here, it will cancel everything. This will be 0, right? So if we say negative e to the power negative s into infinity, right? Let me just use brackets. Okay, before I do that, let me take out the common factor of s. Let me take out this because I hate working with fractions. If you hate working with fractions like me, just take it out, right? Then this is e to the power minus s into infinity into s multiplied by sine of a into infinity plus a cos of a into infinity, right? Then this subtracts, then this will be in bracket minus into minus e to the power minus s into 0 into s multiply sine of a into 0 plus a cos of a into 0, close bracket, right? This will give us 1 over s squared plus a squared. This is 0, right? So we're left with, in bracket, minus into 0, because sine of 0, this is out, 0, is it okay? Then, okay, sorry about that. Okay, let's do this. We'll have this negative, okay, let's use many brackets, this bracket minus into minus, this is going to give us negative 1 into, this is 0 and this is 1 plus 1, right? And this is 1 over s squared plus a squared into negative into 0. Then this is going to be negative 1. Then this is 1 over s squared plus a squared into 1. This is positive 1. This is actually, there's a here, there's a here. Because if you say cos of 0 multiplied by a, is going to give you a. So here we have our a, and this will be a over s squared plus a squared. This is the solution of sine, which is that, right? I had hoped we can record many in one video, but it takes time. So I'm gonna record in the next video. I'm gonna do cos, hopefully do t as well. Don't forget to like, subscribe, and share the content with your friends. See you in the next video. Tango!